Welcome back again. Today I'm going to discuss about the topic called stresses in the machine members. So till now we have seen in the previous course of study, in the unit one, how we are going to select the material and what are the different types of stresses. So generally, the stresses can be classified upon depending upon the load applications and generally the term called stress we are aware about a simple definition we can able to analyze what is a stress is nothing but we people may say that the load by area depending upon the application of the load and the area of that particular element, just we are saying it in a formula or a definition based. So similarly strain depending upon the things which we are discussing. So see everyone, so here we should analyze what are the different types of stresses that are being analyzing in a machine element. So based upon it, we should be able to know why we are learning the concept of stresses in machine parts or machine members. So see whether the particular material or the particular machine element is subject to static or dynamic conditions or dynamic stresses. Simply we can say that the material which we are using in static condition or dynamic condition, depending upon this, the stresses, how they are being induced in that particular element, we are going to notify, right? So with this, I am going into this particular concept. So people can see in this. So at the end of the session, you can able to perceive what are the various stresses in the machine elements or the machine members. Hope you are going to learn this particular topic interestingly. Hope I do so. See, generally, we are aware about what is a machine design. We can say that simply by using a scientific principles, technical information, and you can see it is just an imagination of description of the machine or a mechanical system to perform specific functions with maximum economy and efficiency. So that is the main agenda, not simply designing any product which may take much more cost, but it should not be economy or economic to the user. So in this era, see, the designing of a machining component is necessary to have a good knowledge about many subjects such as mathematics, our previous subjects like engineering mechanics and basics of strength of materials, and you are inducing some kinematics of machinery, theory of machines. Why we are inculcating, because in our design, if we require any uh, whether it may be motions which we transmission of motions or some kinematics if you like or dynamics of machines if you would like to inculcate, then you have to know some little bit concept of theory of machines and some workshop processes and also the engineering drawing. So it is far as far as it is necessity. Why? Because a design engineer must know this is the basic thing called engineering drawing. Okay, see, this is the general procedure that we are following in order to develop or draw or design any product, whether it may be a modified product or it may be a new product, the thing might be. So generally, these are the steps that are to be followed. So see, quickly we'll go through it and understand the things what really happening, right? In designing a machine components, there is no rigid rule like you have to follow these steps, you have to follow. So they may give some generalized examples or statements. So in that, which one is required for our design, those things we have to take it and design the things. Okay. So if we face any problem, may be attempted in several ways and also general procedures which we are following. So we can able to adapt the systems, adapt the process and we can able to select an appropriate procedure for our design, right? See, the steps are being given in a flow chart. So we will go through. Need or aim is nothing but whenever we are starting any design, we should have a problem statement or some problem identification, what really is happening and what solution should be developed in the later stages. We have to get a clarity. So that's nothing but aim of our design. Next is synthesis as nothing but what type of mechanisms we are going to use, what type of things we are going to make the previous things simpler. Okay. For an example, if you say if any mechanisms which are something complicated in structure, so we can able to simplify the things in by using some lesser number of components utilization. Likewise, we can do the things which are harder in during the time of applications. We can make it simpler. That is the thing of this particular design engineer. Okay. Next, analyzing the forces. This is also what type of forces are acting on that particular material, whether it's the tension, compression, or sharing, whatever the things, we have to analyze those. Then only we can able to move on further. Next, selection of the material. This is also one of the important concept. Next step is designing of the. From here, we are going to start the design process, right? After see here in this step, after this particular designing, see generally we will create some prototype or some type, not exactly a prototype. We can say that initially we would draw a rough sketch of that particular design. It is not only confined a single sketch or a single design is not applicable or not satisfying the condition, but several designs are taken into account, and then we have to choose an appropriate design for our need, and then we have to go for the manufacturing. So before manufacturing the products, we have to check it by using some several testings which we can able to do on our material or prototype. Then if we are facing any sort of difficulties, then the next step we have to go for the modification, and then after the modifications we have to again go for a detailed drawing. If these things are okay with it from the production department and the designer, then the particular component or the element can go for the production. Until then we cannot able to go directly from the design to the production. So this one is in between how many steps are playing its importance and role. You can able to observe, you can able to imagine how the in industries the real things are happening, right? See, recognition of the need is the first step. So see here, here we have to be aware about what is the complete statement of the problem. So what the problem is and what type of necessity or compensatory measures which we can able to do. We should have a clarity of it. Okay, it's nothing but we can also call as the aim or the purpose. Next, synthesis. These things, this particular step we know. Why? Because for our design, what are the possible mechanisms which we can able to incorporate? Okay, so it may be a single mechanisms or it may be a group of mechanisms depending upon the desired motions which we require. Based upon it, we can able to design or design the synthesis step. Right. Next, analyzing the forces. So we have to find out the forces that are acting on the each member of the machine element and the energy that is going to be transmitted to the each and every member. That is nothing but analyzing the forces. Next, selection of the material. So in the previous classes I have given you that selection of material is one of the major tasks for the designer. So what type of materials are available, is it is affordable for production, is it satisfying the condition, these are all things the designer should analyze. Okay, so it is a part of the task of the design engineer. So he has to take it as into accountability and he has to design the product on the part. Next, designing elements based upon the stresses and the sizes and depending. See here, you have to find what type of force acting on that particular member and the permissible stresses or nothing but allowable stresses for that particular material that we are using. See, every material is having some sort of factor of safety limit where we can able to maintain that particular material in beyond the stress point, right? So here after the next step, we are going to see how we are going to modify the material if there is any sort of modifications that are required from the previous testing procedures. So if there is any requirement of modifying the design, so we have to do those things. And if it is going to satisfy the condition, if everything is okay, then here one thing you should observe what are the things means generally after the product or the part the design is completed, then they have to go for the analysis procedure. So in this analysis procedure, it is a virtual environment that is going to be done in the industries where the material is going to be tested under the virtual environment by simulation or packages softwares, and they are going to check whether the material can able to withstand the load condition, environmental condition, heat conditions, whatever the things which we would like to check it, we will check it, and then modifications are being done. So this thing I would like to add in this particular point. Okay, I think you people are clear. Next, if everything is okay, we are going for detailed drawing without any errors. We are going to give a good design. We can able to give a good drawing, right? Next, a detailed drawing means we are specifying mentioning each and everything. At the same point, so after everything is completed, these tasks are completed, then we are going for the design procedure. We are before it, we are not at all going. Okay. So what are the factors that are to be considered while the machine design? So during when designing any machine elements, these factors like type of loading means application of load, whether it may be compressive, tensile, or shear. Okay. Next, size of the object, whether that particular object is simple in design or it is some complicated or it may be small size or it may be large size, depending on it, you have to check. Next, environmental conditions. See, some of the plastic components that we are manufacturing, see if it is satisfying the load conditions, but if that particular plastic component is exposed to heat, what is the situation? See, these things we have to analyze. The purpose is satisfying the particular plastic component is ready for manufacturing, it is withstanding the loads, it is very good, it is non-corrosive within. But if that particular material is exposed to heat or heat is being in between that particular if somewhere in the engine or some in industries some heat affected area we are using this plastic component, see how the situation will be, whether it can be able to withstand or not, we should be able to observe, right? The similar fashion, another example I would like to say, if some of the metals continuously exposed to rain, generally they may, if they are not giving some precautionary measures, generally these particular materials may corrode, corrosion factor may implement. So there we have to give some sort of protective coatings, or else we cannot able to find out the material after some years. It's true. So these are all coming under the environmental conditions. Next, the place of employment. So the workers or the persons who are working in the particular industries, see it is whether it's safe for them, for the industry and for the employees, whoever working in that particular areas. Next, safety. It is also see while designing or establishing an industries, we have to be check thoroughly that this particular safety norm is being implemented for the particular industry for employees effectiveness, safety, right? Next, cost of production and establishment cost and production cost and maintenance cost, we should also be analyzed. Okay, so as we have seen, some of the general considerations for machine elements, such as we can see the first one is the selection of the materials for the designers, design engineers, types of loads and stresses that are being acting. Next, you can see some sort of more work facilities and motion moving parts, and also you can see some safety measures and frictional resistance and lubrications. If see some materials, if we are using, it is under a dynamic condition. See, during this dynamic condition, you can able to observe that the material is heated up for some time. After that, see, generally, if we can able to provide some lubrication for that particular element, whether it may be wet lubrication or the dry lubrications, we can able to give some more life for that particular element. So you people may ask that why this is a problem of designer means. Yes, some aspects. See, generally, if you are designing any bearing element or bearing housing, so in that housing, if you can able to provide some space for oil or grease entering into the particular housing, it may be better. Or else, by applying on the outer side of the bearing, it may not able to satisfy. So during the time of the design only, we have to provide some sort of housing or a passage of some fluid or dry. So what I would like to say is some grease elements we can able to put into the particular housing or the pump or bearing housing we can able to incorporate. So next, cost of the construction, right? See, the construction cost should also not be much high. It should be under a reasonable, and the cost of production and cost of establishment and maintenance cost should not be much more higher than the average values, and also usage of standard parts. So generally in industries, we are using some standard parts and materials in order to reduce. So here I would like to give you a best example. See, any automotive manufacturing industries, see, each and every component will not be produced by the particular manufacturer. Will you agree it or not? See, machine engine components are being assembled by different manufacturers who are producing a particular components. If you can observe the engine, if that particular industry is being produced, whatever the industry, see some headlamps, tail lamps, tires, and at, some electrical devices, all are not coming under the same brand manufacturer. Different elements are being observed from the different manufacturers, and we are assembling it into a single unit. So if each and everything will be designed by the same brand or the manufacturer, it may take much more time and we cannot able to deliver the product on the time. So these are some of the things that are going to follow. So if we can able to use some standard components also, we can able to reduce the designing time, and our time of the design also can be reduced. So strength, the ability of the material to resist stiffness, also resist the ability to resist the material under deformations and elasticity, likewise ductility, the property of the material that can be drawn into thin wires, malleability, the ability of the material to drawn into thin shades under compressive loading, brittleness. These things we are better understood by using cast iron phenomenon, where the material is hard, but if any sudden load can be acted on that particular material, it may be damaged. Toughness. It is a property of the material to resist the fracture due to high impact loads. Good example, hammer blows. If that particular material can able to withstand, we can say that material is having toughness. Resilience. It is the ability of the material to absorb the energy when deformed elastically, and also release the energy when it's unloaded. So taking the energy, absorbing it, keeping it, and releasing after the load is released. Okay. Especially in spring type of elements, we can see the resilience property. Especially for that only, I have given you the example. Next, creep. So creep, I have explained you in the class, and again I am saying you that It is a slow and progressive deformation that can be especially seen in IC engines, boilers. Why? Because slow and permanent deformation, progressive and permanent deformations can be observed, like turbine blades, rocket engines, nuclear reactors, etc. Fatigue. When the material is subjected to repeated blow, it fails under the yield point, below the yield point stresses. Best example is engine crankshafts, where we are applying cyclic and periodic loads are being applied at some period of time. If these are not abnormal, abnormal loads are being falling on it, it may undergo breaking phenomena. Crack can be able to observe. So if this material can able to withstand, then we can say this material is subjected to fatigue, whereas loads can be able to withstand, we can able to say hardness. It is also a property where the resistance to wear, scratching, deformation, machinability. Okay, we can able to check it by using in our laboratory. You have seen that Brittle hardness, Rockwell hardness test, and also Vickers hardness test is also used for checking the hardness. Right. So here we have seen the different properties and selection of the materials, which type of materials, mechanical properties, what are there, and depending on it. The next class we are going to see about what are the properties depending upon the composition of the materials and what type of materials which we have to choose. There in the next upcoming classes we are going to discuss. So see some sample question I have placed here. Right, please go through it. And the next topic, selection of materials for the engineering purposes. So there we are going to see some compositions of the material and what type of materials we are going to absorb for our design. Right. Thank you very much. Have a nice day.